Welcome to this demo developed by Nutaq. In this demo, we will showcase Nutaq's second generation PicoSDR 8x8 system and explain how it can be used together with Matlab's LTE toolbox to address various features of LTE Advanced. A 1000-fold increase in network capacity requires increases in all dimensions: efficiency, spectrum utilization, and density. As consumers start to use media more intensively, another challenge is their continuously rising expectations of throughput and service. By 2020, a typical user will consume 1 gigabyte of data per day. LTE 3GPP Release 12 and beyond will provide a foundation to meet these challenging demands while paving the way towards the 5G era. End user experience, capacity, and coverage will be improved with small cell enhancements based on inter-carrier site aggregation. Improvements in capacity and more robust network performance can be achieved by 3D MIMO, advanced user terminals, and evolved coordinated multi-point techniques, as well as through self-organizing networks for small cell deployments. 3D MIMO techniques that simultaneously exploit both azimuth and elevation of the multipath channel to suit each user have been explored. These techniques are expected to give significant improvements in both the cell edge and sector capacity. The following demo showcases MIMO uplink processing of real-world E-Node B downlink signal using 2D antenna array with 16 elements. The 20 MHz LTE signal at 2.21 GHz is recorded using the second generation PicoSDR from Nutaq, and further processing to detect the E-Node B master and system information block is done using LTE toolbox from Matlab. The picture shown here depicts one 8x8 PicoSDR with an antenna array that is arranged in 2x8 configuration. Any arrangement is possible, but for the sake of the demo, only 2x4 is used. Here, we show the hardware setup used in this demo. As you can see, the PicoSDR is equipped with two double-stack Radio 640 FMC modules as well as a DDR3 SODIMM RAM placed right next to the bottom Radio 640 FMC double-stack module. Finally, the green Ethernet cable, which you can see at the back, connects the PicoSDR 8x8 to the host machine running Matlab. On the host machine, the initialization script enables the user to set the RF frequency, the receiver AGC mode, and analog or baseband filter as shown. Once all the parameters are configured, a single click will suffice to record a live E-Node B signal at 2.21 GHz. The IQ samples from all 8 receiving chains are recorded in record.bin file. The record.bin file is processed to remove extra IQ samples prior to MIB SIB1 extraction using LTE toolbox from MathWorks. The end results show that MIB and SIB are successfully decoded. One can further examine the supported transmission mode, bandwidth, and more. Looking closely at the SIB1 information, the mobile network code and mobile country code can easily be distinguished. Even though the demo is based on MIB and SIB detection using 8x8 second generation PicoSDR, it also showcases how easy it is to use Matlab and LTE toolbox to address the new features of LTE Advanced such as FDD MIMO and more. The antenna array size can be scaled to 16 by 16 and more to approach an almost massive MIMO setup and hence pave the way to 5G. Nutaq's second generation PicoSDR platforms will assist you for LTE Advanced development all the way to 5G.